Hello viewers, welcome to my YouTube channel. In this presentation, I'm going to teach you guys how to plot graphs. That is what we are going to discuss in this video. How to plot graphs. You have to know that in plotting graphs, there are elements you have to consider. For instance, a good graph must have labels. Yes, the graph must have labels. So you should have labelings. So a good graph should have labelings. That means the quantities you have plotted must be indicated clearly. Number two, that's the first one. Number two, a good graph should have what? A very good scale. There is nothing like the best scale. This is the heart of every graph, and that is what we are going to discuss in this video. Because when we choose a good scale, to make plotting of point become very easy, and to do calculation from the graph, it also becomes very easy. So I'm going to teach you guys how to take a scale. When you are given data, this video, when you are giving a let's say data in table form relating two variables, right? That is what we want to see how we can plot that graph. Remember, a graph, our graph is always plotted on the Cartesian plane. The Cartesian plane is made of two perpendicular axes, which are known as the Cartesian the XY plane or the Cartesian plane. In this plane, the point where these two points meet is called the origin, and the quantities here means that you are plotting the quantity y against the quantity x. So that's what this virtually means. Now let's discuss on labelings. Labelings of a graph. I'll illustrate with an example. We have a question here that says a student conducted or investigated the variation of the electrostatic force with separation arrow between 2 point charges, or each with a charge of magnitude 12.0 microcoulomb, and the results obtained were displayed in the table below. So they gave the separation in centimeters, and we have the force in newtons. So we had 12.0, 13.0, 13.5, 14.0, 16.0, 16.5, 17.0, and 17.5. So those are the values for the separation that the student used, and these were the corresponding values for the force that student obtained. So we had this written down. When the separation was 16, the force was 50.63, and we have 47.60, 43.80, and now 42.32. That is virtually what we have for the data that was obtained by that student during his or experiment. Now, the question now is, I just want to show you guys how to choose a scale, right, using that data. Assuming I was to plot the electrostatic force against the separation distance, how am I going to proceed to do that? Like I said, the XY plane, right? My graph paper, remember, graphs are plotted on graph paper. A graph paper, a graph paper has 23, 23, it's made of 23 units on the vertical axis and 18 units on the horizontal axis. Those lines you have 1, 2, 3, 4, 5. Those are the units. This is 1 centimeter, 2 centimeters, 3 centimeters, 4 centimeters. So each line represents 1 centimeter represent 1 unit. So there are 18 of these units here, and we have 23 of these units on the vertical axis. 23 of them. So since this is just a presentation on how to plot graphs, I will not plot the graph here, but I will show you the details how you can plot the graph of F versus R. The very first thing, when I want to plot a graph, I identify the units of the quantities I want to plot. I'm plotting force, for instance. If I want to plot the force against the separation distance, since I'm plotting force against separation distance, the force will go on the y, the vertical axis, And on the horizontal axis, I have the separation. It's measured in what? Centimeters. I indicate it like that. Once that is done, I now come here. The next thing is to take a scale that will cover this data from 12 to 17.5. Now, how do I choose a scale? The first thing, these are the techniques on how you choose your scale, right? For the separation axis, let me start with that. I know that if I want to plot this graph, the first value is the lowest value is 12, the highest value is this, right? So for me to know the scale, I will determine the range of these values, the range of the value, right? So the range of the quantity r, let me just denote it capital R of small r, with the range of these values is given by the highest value minus the lowest value, which is 12.0. And when you evaluate that, 17.5 minus 12.0, I'm going to have 5.5. Once I have the range for the separation, I do the same thing for the force. For the force, the range is what? Range of the force F will be equal to what? Highest value is 90. The lowest value is what? You observe your eyes. The lowest value can be up here. The highest can be down here. Among these numbers, the highest value is 90 and the lowest value is 42.32. So I have 90.0 minus 42.32. So 90.0 minus 42.32. So I have 90.0 minus 42.32. And I have 47.68. That is the range for each of the data I want to plot. Once you get the range, right, you now look for what? The subunit. Remember, we are choosing a scale that will cover at least 75% of our graph paper. So since I have 18 of these lines here, 18 units, I might decide to start from 16, because if I start from 14, that is actually 75%. You can start from there, but it's advisable for you to start at the point where you have at least 2 units ahead of it. So that's, you leave out 2 units from 18, which is 16, right? And now go, I divide since it is arrow on that axis, right? I'll look for what? This thing, 1 unit. Since here I have from here to here like this, right? The range is what? The range is what? 55.5 centimeters, right? That is my range. My problem now is, if this one is like this, how do I get now one of these, right? So I've decided to work with 16 of those units. Let's say here we have 16, right? So it means that to calculate this, one of these will be equal to what? I will now take 5.5 divided by what? 16, because I've chosen 16 centimeters, right? So now from there, it follows that, look at it, even you can still use simple proportion to do this, to look for the range. Look at it. Like I said, you can use simple proportion to look for what is the value for 1 centimeter. How many units does it represent? So on my graph, since I've decided to choose the 16 of those 16 lines to represent this range, right? So I say that what, if 16 centimeters represent 5.5 units, right? It means that what, 1 centimeter will represent x. By simple proportion, x will be what? 5.5 divided by what? 16, which is equals to what? So I take 5.5 divided by 16. That is, look at the value I have, 0.34375. That is the value I have, right, for each unit. But now, that value is that value is too long, because I'll be writing this. That is, each of these lines, right, represents 0.333434375. That value is so long, right? What I'll do is this: I'll scale it down to 2 decimal places. So this one is approximately 0.3. Now that is what, 34. So I have 0.34. That is for the unit on the x. So my graph, look at it. The lowest value started from 12, right? So my graph will not begin at the origin. So the first value here, I'm going to put 12 there, 12.0. Since each of these lines is what? 0.34. I will now come here and add 12 plus 0.34. What do I have? So 12 plus 0.34, I'm going to have 12.34. You see that if I want to be writing all these values, right, it will make my scale so choked up. So since I know that here is 0.34, and then between all these lines, each is 0.34, I might decide to take, since from here I've seen that my 1 centimeter represents 0.34, right? I can now try to say, maybe for instance 3. I can take for instance 3, 3, 3 and see what it goes. So I can take 3 units or 3 centimeters to represent something. Since 1 represents this, then 3 centimeters will be what? 3 times that, right? Or you can do this. Since we started with 16 lines, right? I might take a factor of 16. If it's an odd number, right? You are free, you are good to go. But let's use 3 and see what we get. So I'll take 3 centimeters to represent what? X. So 3 times that. So it's 3 times 0.34. And when I do that, I'm going to get 0.34 times 3. That's 1.02. So rather than writing this thing, adding it consecutively, it will make my scale so choked up, right? So what I'll do is this. Since I've saying that for every after 3 centimeters, I add 1.2 to the previous value. So I have 12.0. I count 1, 2, 3. Here I'll add 12.0 plus this one. So I'm going to have 13.02. I count again 1, 2, 3. I put the next 13.02 plus 1.02. That's what 14.04. I'll keep adding like that until I get to the final end of my graph paper on that axis. That is how I have chosen my scale for the values of R. Let's see how we choose for F. For F now, I'll do the same thing. Highest value minus lowest value. I had 47.68. Then I'll calculate now what? Since I have this one here has this vertical axis has 23 lines, so it represents 23 units vertically. Like I said, you always leave out 2 units. So I'll leave out 2 units. So 23 minus 2, that's 21. 21. So I can take 21, or I can even start from 20. So let's say I choose by 20, right? So it means that my 20 centimeters is representing this full scale. This is my range. So it's 47.68. Once I have this now, I now calculate for 1 unit. It means that 1 centimeter will be equal to what? So 1 centimeter will be 47.68 divided by 20. So I have 47.68 divided by 20. I'm going to have 2.384. Like I said, you always round it up to the nearest 2 decimal places actually. So I'm going to have 2.38. You can use this one, it will work. It's a very good scale. And to be sure that your data will enter, this is what I will do. Initially, I know that the lowest value of my graph there is what? 42.32, right? And I know that this 1 centimeter like this represents 2.38. 2.38. So each of this one like this represents 2.38. 2.38. So I can decide if I'm adding 2.38 consecutively, my scale becomes so choked up. So in that case, what will I do? I will simply take this one. I can maybe try to group in terms of 3, 3 or 4, 4 or 5, 5, depending on you. Right? So let me say I choose 4, 4. So I'll say for every 4 unit, 4 centimeter will be equal to what? Since 1 is equal to this, means that 4 will be equal to what? 4 into what? 2.38. 2.38 times 4. I'm going to have 2.38 times 4. I'm going to have 9.52. So instead of adding this 2.38 to the previous values, I would rather count 4 centimeters and add 9.52 to the previous value. This is just to make your scale flexible and not choke up. So I count 1, 2, 3, 4. I add 9.8 to this starting value. So I add plus 42.32. So I have 1, 2, 3, 4. So this is the fourth line, 51.84. I count the next 1, 2, 3, 4, and I keep adding what I have there, right? So that's how you choose your scale. Now let me give you hints on how you do your approximation. Like I said, in choosing the full scale, first of all, you make sure that you leave out 2 units here and 2 units here as well on the vertical and horizontal axis before you say if this number of units you have chosen represent the full scale. That's the range of your data. Then now, what will 1 centimeter represent? You calculate it. So this is that means 1 centimeter on my graph represents 0.34 units. Now I want to give you hints on how to do your approximation. Let's say for instance, you calculated this and you had this, right? Another person can decide to, let's say if I'm rounding this one, if I wanted to round up, you see that 3 is less than 4. So I'm still going to have 0.34, right? Another person can take the closest value to this 4, which is 5. So another person can take 0.35 and it will cover all the data. How are you sure that it will cover it? Since I know that that is this one, I've chosen what a total of what 16 lines for instance, 16 lines. So I'll take now this my value. This is 0.35 multiplied by 16. That will give me 5.6. 5.6. And I know that my total value is more at 17, but my graph is starting at what? 12. 12 plus 5.6. That will give me what? 17.6. You see that it is just slightly greater than by this value by just 0.1. So you see that it has covered all the data points. So that's a good scale. And I hope everyone has understood. From there now, once you have chosen your scale, right, I can write it there that 1 centimeter equals what? We had 1 centimeter to be equals to 2.38. So after using this thing to choose to approximate the value to two decimal places, it can also be a whole number, right? You can do your calculation and end up with a whole number, so that will even be very nice and easy to use. Whenever this mass comes, you know how to do it. Now, um, since we have done this now, the question now is, how are you able to use this graph? I'm using 1 centimeter to represent 2.3 on this vertical axis. I've also used here 1 centimeter to represent what? 1 centimeter represent what? We had 0.334 unit. That's what I'll be using to plot my graph. So the rest now, remember, all what we are doing is rough work. You can show it on your answer sheet that 1 centimeter is equal to this and 1 centimeter is equal to this. So this one is rough work, right? So let me clean it up so that we have space to do the others. Now, once we have our scale in contact, once we have chosen a correct scale, the next thing is now, how can we use that scale to plot points on my graph, to plot points on the graph? So that's a very big question. How can you use that scale to plot points on your graph? I come here, observe. If I want to plot, let's say for instance, if I want to plot for instance, let's say, let me come here, this value. I want to plot f, that's 71. Or better still, let me take something that is really in the range. Let me take something that is in the range. Okay, for instance, let's take this one. Let's take this value. Like I said, we decided to count 3 units here to add to that. So I take 0.34 multiplied by even 4, for instance. So it means if I count 1, 2, 3, 4, I add to 12, I'm going to have 13, 1, 2, 3, 4. So I have what? 13.36. 1, 2, 3, 3, 4. Then so I take 13.36 plus 1.36. So I have here number 1, 2, 3, 4. Let me extend my this thing. 14.72. This is just to show you how you can plot a point using your scale now. Look at it. Observe. This is how I used to my own to plot. This is how I do my plotting. I will do this one for both axes. Plotting these decimals are very strenuous, right? In that case, I would rather prefer to plot whole numbers. Whole numbers. So in that case, I will calculate the whole number part of each of these data. Each of these data. Remember, all what we are doing now is rough work. It should not be indicated on your answer sheet. This is what will help you in plotting your graph. So to do the whole numbers, to calculate the whole number part, right, of data, because whole number part of U will be equals to what? You take the data point. So this is data point divided by sub units. So I call my data point D and my sub unit S. So my whole number part W is D on S. What are sub units? Look at it on your graph paper. We have these small marks there, small lines in between the long lines. So remember there are 4 of them inside here, and from here to here it spans 5 of them, right? For each 1 centimeter, we have 5 sub units there, right? So to know one of these lines, since I've said that 1 centimeter is equal to this, I know that in 1 centimeter we have 5 sub units, right? So I'm going to say that what for this one, we are calculating now for what r in centimeters. So I'll calculate the sub unit of this my scale here. So I'll calculate my S by taking the value that I have for 1 centimeter divided by what? the number of subunits there to get that for 1. So if 5 subunits is equals to 0.3, because we say in 1 centimeter we have 5 subunits there. So I'm going to have what? 0.34 divided by 5. And what do I get? 0.34 divided by 5. I'm going to have, you can leave it like this. You can leave it like that. You must not even write it out in full. So if this is my subunit, it means that my whole number part will become what? Z on what? S. My S now is what? 0.34 ordered on 5. And when I simplify this, I have 5Z divided by what? 0.34. So that's the whole number part I will use to calculate for R. So I'll indicate it there for R. I keep that aside. This is what I need. So I can clean up everything now. So the only thing I need here is the use of R, which is what? 5Z divided by 0.34. I call this a whole number part for the quantity R measured in centimeters. Now, so that's what I need. I do the same thing for the force axis, for the force. Now, like I said, for this axis, 1 centimeter represents what? 2.38. It means that what? Remember, always remember that we have 5 sub-units. It means that my sub-unit will now be what? 2.38 divided by 5. Because we have 5 sub-units here, it means 1 sub-unit will equal to what? This value divided by that, by 5. So I take 2.38 divided by 5. That is 0. Like I said, there's no need even dividing. You can leave it like this. So now my whole number part for F, the force, will be what? Data point divided by data point Z divided by the subunit S. So I have what? 2.38 divided by 5. So this one will give me 5Z divided by what? 2.38. So this is what I need for F. Let me write it down somewhere. So the use of F is equals to what? 5Z divided by what? 2.38. This is when we are plotting now. So I'm done with that. So the only thing I have to indicate on my graph, just by indicating the units plotted and a good scale indicated like this, you have 2 marks, just like that, 2 marks without even plotting the graph. Now let's see how we can use now the whole number part to plot our points on the graph paper. This is what I will do. Since I want to plot the whole numbers, not decimals like I have here, right? I'll create another table for R and also create another table for F. R in centimeters. This is what don't indicate on the answer sheet in newtons. So the first value is 12. My data point for R, the first value is 12. What would the corresponding whole number? We say it's 5 times Z over that. My Z is what? 12. So I take 5 times what? 0.5 times 12 divided by 0.34. In that case, I'm going to have 100. You take it to the nearest whole number. I have 176 here. The nearest whole number. You round the value to the nearest whole number. I do for 91. I mean 90. When the force, for the force, I say it's 5D divided by this. I now calculate 90 times what? Because these are the data points we are talking about. So I take 90 times 5 divided by 2.38. So I'm going to have 189. Once I have that, the next thing now is for me to see how I can use those values, those whole numbers. You do it and continue like that. So for simplicity, I will just continue what I have started. You continue like that, continue until you get to the last value. Keep calculating that until you get to the last value. Like I said, let me use this one. I want to show you how you plot this one using the whole numbers. So let me calculate. 14 is for arrow. So I have 5 times 14 divided by 0.34. So that's 206 to the nearest whole number. 206 to the nearest whole number. Then for 66.1, that's for the first. So I have 66.12 times 5 divided by 2.38. I'm going to have 139 to the nearest whole number. You round your answer to the nearest whole number. So now what I'll do is this. I will now, since I want to plot whole number side, you do it for all the data points. That's how you plot it. Follow up what I'm doing now. I come here, I locate. This is what? 12, right? What is this value? 12 is a data point. So I start. What is 12 representing in data point? I have 176 because I've already calculated, right? If you have not calculated, this 12 goes for what? Arrow. So you calculated the whole number part for 12. You indicate it there with a pencil because at the end of the exercise, you erase everything, right? So after that, I now count. This is 106. 106. the whole number part. I know that I have 1, 2, 3, 4 before 5. Those small lines, we count them 1 unit, 1 unit. So I have what? So here is 5. So I add 167 plus 5. You keep, you see, if you're adding this one, we waste a lot of time, right? So without wasting much time, I'll be adding the what? This is 5, 10. So after every 2, I add 10 to the previous value. So 10 plus this is what? 100 and what? 86. I keep adding like that. This one you can indicate now inside here 186, 196, 206, and so on, right? You keep continuing like that. Then you have after sorry, this is 206. After skip 2 again, it's 1 year. This is what? 216. You're adding 10, 10, 10 because this distance is 5, 5. So from here to here is 10. You start from here. Okay, now what is this one representing? On the first axis, we say that it is 189. This value here. So in that case, so this one represents 189. So the next one here, this one will represent what? I will now take 189 times plus 10. That's what? 199 plus 10 again, 209. This is 5. So after every one you skip, so you add 10. So this is 209. I skip, I continue like that until I get the target. So remember, we said that each of these things represent this. I said for the next 4 we can add we can multiply by 4. So I have 2.38 times 4. We were adding 9.52. So let me add 9.52. I want to get this value. So I'll show you how to plot it. So you continue this numbering, right? For the scale that you choose. This is what the examiner wants to mark. Plus 51.84. And I'll put here 1, 2, 3, number 4. I'll put what? This is 51.12. I continue 1, 2, 3, 4. Add 9.52 again. So I have what? 70.88. You continue like that until you hit the target. Now, I will come here and plot. Since I don't want to stress myself on plotting decimals, I'll plot whole numbers 206, 139. Like I said, this is 209. So the next one, the next 2, I add 10. This is what? 200 and what? 19. I add 10 again. 200 and what? 20, 29. 289, and so on. So I'll come here now. I'll locate where 206 is located on the R. I locate 206. This is 206 automatically, right? So you count. If it was 190, say 95. So this is 196. So one of these small line after is 196. So you see how easy it's very easy to plot using whole numbers. So I locate this point. I'll follow the line on my graph paper. Those small lines now. Then I also locate for the first 139. 139 is where? 139. With there was an error here. Let me calculate for 66 and so I get. For the first 66, 66 times 66.12 times 5 divided by 2. 2.38. I'm going to have 139. Okay. Then let me calculate for 90. Let me calculate for 44 again. I'm not very certain about this value here. So let me change the number. There is a little error at this point. What does 44 represent? 44.2. I've not yet calculated. Instead, what I did was this value I indicated there. That one was going for 90. This is for 90 instead. So the value I wanted to take was this 44. What does it represent? So I'll take 44 is the data point on the first axis. So I'm going to have 5 times 42.32 divided by 2.38. So it is actually the same thing. Nothing will change. So this is 89 in whole number. So if here is 89, after 2 I add 10. That will be what? 99. By adding 10 now, after 2. Well, each of this is 5. You can add 5, 5. You will make your work too crowded. So you add 10, 10. So I add 10 again, 109, 119, and so on, right? So after 2, I add 129. After 10 again, I add 10, 139, and so on. You keep going like that. So I'll come here. I've located this one on the first axis at 139. So this is 129. 139 is here, right? I'll now follow that line, follow this line. So where the 2 points intersect like that, I plot my point here, maybe with a star, and then circle it, or you can just put a dot where they intersect. Right? I plotted that point. That is how you do to plot all the other points by calculating the corresponding whole number parts and locating them like this, the way I did. At the end of the exercise, right, you might have plotted a lot of points. Normally, when you plot the force of F versus R, the graph will look somehow like this. When you plot it, when you plot the curve, because the electrostatic force the electrostatic force between 2 point charges, we have K, Q1, Q2 divided by R squared. So if I plot a graph of F against R, I know that it will look something like that. Then, for the sake of simplicity now, I will just show you guys how this one may look like this one, how to plot this point. This is where my point is located. So you do same to plot the other points, following the same procedure. Now let me say I've plotted several points, right? Maybe I have something like this, and I've drawn my best straight line, for instance. My point now is how do I read off these data values that I will use in calculating my slope? I now draw a very large triangle that does not touch any of the points that have been plotted, but it should be points on the line. Now to know x1, y1, then I also know x2, y2, those points here. This one is the one you get from here. You see that it's not easy to get, right? So I will still go by whole number part. I read off the whole number that I'm meeting here. So if here is 205, I note it that for this one, for the x on r axis is 205. So since on r axis I have WR equals 5D on this, so it means that my D will be what? 0.34 WR divided by 5. You make D the subject. Now you want to note by what the data point. So I'll now take the whole number that I got here, and then I multiply by the use of R divided by 5. I put the answer here. I do same for Y. The value I will make here for the whole number, then I will come and make D the subject here for F, and I put it. Do same to get this point here. The value you get here, the whole number, and here. Once you have done all these parameters I've discussed, then you plot a good graph and you have a good shape. And all calculations done from your graph will be accurate. So that was the little thing I have for you guys. And please, if you have not subscribed to this channel, please, I beg you to subscribe, share the video, like, comment, and this thing will encourage me to work harder, produce more content for you guys. I love you guys. Bye. Please, like I said, if you have not subscribed, I am on my knees begging you to subscribe. Please subscribe to this channel just to support me. That would encourage me. It is very important for me. Subscribe and like the video, share, comment, share the video. Most importantly, after subscribing, share the video and place your comment in my comment section where you need more explanation on plotting graphs. You can send me an email on this mail address, temroom48 at gmail.com. So that's my mail address. You can now send me or contact me on WhatsApp 652186890. So 652186890. I am from Cameroon. So that's my country code 237. My telephone line, my country 237. So like I said, place your comments in the comment section. I'll be releasing more content on choosing maybe on answering maybe examination questions full-fledged. So I've just demonstrated something here, how to choose your scale from the data you have to plot, right? Don't go if you had manipulated data, you not use the original data, but use the data that has been manipulated to plot, and that is where you choose your scale. Bye. So following what I did, and this is a sample of how my work looks like, very neat. This is not the exercise I was answering, it's just a paper that I've solved, and I would like to show you guys a bit of it. Look at how my graph is very neat and clean because I've chosen a good scale and all the points are well plotted. My triangle is very large and all calculations made from this graph, they are accurate. So that is all I have for you guys. So see you again. Bye.